Okay, so hi everyone, Senan this side, and in this video we are going to discuss combination sum 2 problem on LeetCode. So this is our daily LeetCode question, and before solving this, I urge you to watch combination sum 1 or at least solve combination sum 1 because that is very important to understand this question. Although you can do it without that as well, but having an idea of combination sum 1 would be of great help. So what is given is a collection of candidates, and a target number target. Find all unique combinations in candidates where the candidate numbers sum to target. Each number in candidates may only be used once in the combination. That is fine. The only thing that is differentiating from combination sum 1 is that in this case we can only use a single element once, and the uniqueness of candidate values is not present. So there can be unique same duplicate values in the list of candidates like this 1 and 1. In this case we have 3 times 2. Fine, let's look at some test cases. So 10 1 2 7 6 1 5, so we can have 1 plus 1 plus 6 is 8, 1 plus 2 plus 5 is again 8, 1 plus 7 is 8, 2 plus 6 is 8, and we need to return this list of numbers. Now since there are duplicate values present, so let's say if I try to find with starting with this one, I can find 2 and 5, so I get this. But if I try to find with this one, I would again get 1, 2 and 5. So I would have repeated elements. Now to counter this, what you can do is basically use the set data structure, which would take login for adding elements to it, but that using that it would be helpful to keep track of unique elements, because set always stores unique elements, so you do not have to basically think on how to implement uniqueness. I did that before solving with this approach, but that gave me a time limit exceeded for some reason. But anyways, let's look at this combination sum 2. So to keep track of duplicates and not using the set data structure, what I would do is basically sort the elements. That is basically the classic way when you have to keep track of unique elements and you do not have a set data structure available or is allowed to be used. Now other things are same as combination sum 1 that I did. You have a vector int temp that would store your current possible solution. You have your vector answer, you have 0 target candidates temp answer. So this is all same as I did in combination sum 1. If you want you can watch that, but that's not necessary. Okay, so let's look at combination sum 2. So it takes an integer I, a target, candidates, temp, and basically this answer as well. So the logic is this: whenever you call combination sum for I, it would try to, let's say since the list is sorted, in this case let's see 1 comma 222 comma 5 at index I, starting from index I till the end of the list, am I able to get this target value or not? So that is what this recursive function is doing. Starting from index I to the end of the index, can I get this target value? So that is the whole logic. So what I do is I would start from j is equal to I and go till the end of the list. And what I would do is assume that the current element, I'll discuss these two statements later on. What I would do is I would take this candidates of j as a possible solution to my answer. So I would push back into this temporary array and taking this at the jth element. If I take the jth element, what I would do is for the remaining elements after j, that is j plus 1 till the end of elements, end of the list, I would try to find this combination sum. But since I have taken already this candidates of j, my new target would be reduced by this value, target minus candidates of j. Fine. If you think of this recursively, this would make more sense. And in the end, since let's say if we have all the answers stored using this in the answer array, what I would do is I just remove that element again, because when we pushed this element candidates of j, we changed the state, right? So we need to revert back the state as well before returning. Then you do this each and every time. So starting from the first, let's say these elements are sorted. So if I call for 0, I either take this and find, I take 2 and find the solution using the remaining list, or I can take 5 and find the solution from the remaining list, or I could take this to find the solution from the remaining list, and I go on and on till I find a solution or I reach the base case. So what is the base case? So base case is basically if target is equal to 0, that means we have found a valid sum of numbers in our temporary array that is actually equal to the target that was initially given. So what I do is I append that element or that vector into our answer vector and I just return. The second base case is if I is beyond the indices of the max length of candidates. So I is at candidates.size or even more. So that means I am not at a valid index in the candidates. So in that case, what would happen? So if you look, if j is equal to I and I is candidates.size, because of this condition, we won't ever go into this for loop. So if I crosses candidates.size -1, we would directly return. So this is the another base case that I have not explicitly written, but that is basically understood because this for loop won't ever be executed. Now, before you change this video and thinking that you did not understand the solution, just wait for a moment, look at the recursion tree that I am about to show you, and that would make things very clear. Okay, so here we are in our notebook. So let's use the second test case and try to solve that thing. So this is basically, this is your given query, and what you do is basically sort this. And if you look, this is basically the indices of these elements. So the first, the com sum 2 is written as f, and this is the index and this is the target value. I've not carried the vectors because that's just tedious. This is the structure of a temporary array at this point of time. So I call I is equal to 0 and I call target as 5. So at index 0, from index 0, can I possibly solve this com sum 2 with target 5? So this is the question. So in that case, what I could do is either I can take this element and I call the same function for the remaining list. So if that is the case, that means my target would be reduced by 1 because I have taken this one, right? So if you see, we have taken this one, and let's solve for the remaining portion of the candidates array. Similarly, let's say I do not take this one, I take this 2, right? Since I take this 2, what would happen is my temporary list would become this, and my target would reduced by 2 because I've taken 2 as a part of my solution. And since I've taken this 2, I would call the recursive function for the remaining array. So that is starting from index 2, this index 2 to the till the end. Now if you see, there are two crosses. We are not calling for this 2 and this 2 because since we have already considered this 2 starting with this 2, and if we go along this chain and let's say we don't consider this but we consider this 2, so we would basically have some repeated elements, right? We could have repeated elements. So since if you see this 2, later on we got 2 comma 2, we can also get this using this 2, and this 2 we can again get this 2 comma 2 using this 2, and using this 2 and this 2 again we could get this 2 comma 2. So that is what we are trying to avoid. So in the code explanation I left 2 lines, right? So that is for not checking these two elements. If I have considered this, I won't be going for these two elements. In the end, if you see, rather than, so starting from 0, I say let's directly go to 5. Let's directly take the last element, that is at index 4. So I take this, so I pass 4 plus 1, that is the next index. So I pass 5, and since my target is 0 because I've taken this 5 into consideration, that means my target now reduces to 0. In that case, I would go into the first base case, that is if target is 0, append this to the answer. So 5 is one of your answer. This is the first way. Now let's look at this case. So if f is 1 comma 4, that means starting from, let's say I have taken this into consideration, that is stored intent. Starting from this index till the end, can I find the combination sum such that the sum is actually equal to 4? Similarly, I recursively call a sub case, so that is I take this into consideration as well. So I take this 2, I don't perform these computation because these 2 would be repeated, and in the end, since 5 is greater than the target, so I cannot possibly take this, so I break out of this loop. So the crosses here are basically because of the two if statement that I am yet to explain it to you. So after this I would go there and I would do the explanation. Now let's look at the another possible case is when we reach here. So at index 2, what I am saying is calling the function for 2 and onwards for a target 2. Can I find a target sum of 2 in the remaining portion of the array? So currently I have 1 comma 2 as a solution till now. This could be a possible solution. So what I do is, okay, so 2 comma 2, I take this 2, right, and I push that into the array. So this is that 2, and now for the remaining I would call, the call would be starting from 3. So 3, and the new target would be 0 because I've taken this 2, so new target is 0. And since we are since the target is 0, the first base case would be executed. That means we have a solution, and this would also be appended into our answer list. In this case, again, since we have a repeated element like this, we don't go here, and we don't take this 5 because of the break statement, because this value is greater than the target, so we cannot actually achieve this any further. This array is sorted. Similarly, if you come here, so starting from index 2 to till the end, and I want to target sum of, so currently I have 2 in our temporary array. So what I can do is basically either I can take this element, right? If I take this element, I have target as 1, and I would start, since I have taken this, I would start from the remaining list, 3 comma 1, so I get 2 comma 2 as list. And since I'm already at starting from this 2 indices, I would never actually get a target 1, because 2 is greater than 1, then I would just break out of this for loop that I had. Similarly, I won't go here because the same 2 is again repeated, so I don't look at the repeated computation. Also, if I take 5, the last element, as the starting position after this, that is actually this number, 5 is greater than the target, so I don't actually continue ahead. So this was the whole computation tree of this whole code for this test case. I would like you to try it out for yourself. Now let's look at the two if else statement that I left. Okay, so if at any time candidates of j is greater than target, that means the elements are j and after j are greater than target because the array is sorted. In that case, what would happen is we won't be calling this function, because target minus candidates of j would be a negative value, and we are not checking for negative at all, right? So target, if negative target value would never be achieved, because every element in candidates I is positive, target is also positive, so we don't even look at it, so we break out of the loop. That was one of the cases. Again, if j is greater than I, not for the first case, but if j is greater than I and j is equal to the previous current candidate is equal to the previous candidate, that means I have checked this element previously, so I won't do the same computation again for our different j values. That is why we just continue. So that was the whole code. Hope you understood something. If yes, be sure to share it with someone that you think might benefit from these videos. If you want, I can just submit this and show you that the code is running fine. Okay, so clearly 60.85% good enough. Now what I would say is, what is the time and space complexity? So basically, roughly you can say that it's some sort of exponential we are taking and not taking, and in itself we are having a for loop, so 2 to the power n times n, something like that. Space complexity, don't even bother, because in the worst case you would store all the elements in this temporary array, so that will be big O of n. And yep, that is the video. Okay, so the time complexity is somewhere about 2 n times 2 to the power k. How do we see that? If you write the recursive relation for this comp sum 2, let's say t of n, t of n, that would be equal to k times t of, or not k times, n times n minus 1, something like this. Now just use any possible way you can solve this. So you, in the worst case, you traverse the whole list, so that is this n, and each iteration you do the same computation but for an array that is one smaller in length. So if you solve this recursive relation, I hope you would get the exact time complexity. So that is the video, and hope you enjoyed this, and bye.